Alright, so today we're going to talk about a inclined plane problem, right? The problem in statics, obviously one of many problems, but the most common and the easiest, in my opinion, of the statics problems. Static meaning not moving. Funny story, I just recorded this video about 10 minutes ago and just stopped recording and realized that I wasn't actually recording anything, so I was basically talking to myself. So instead of erasing everything and doing everything again, I'm just going to go through the problem, right? So the problem states, if you can't already tell, a 2 kilogram block rests on a 34-degree incline. If the coefficient of static friction is 0.2, how much additional force, F in this case, must be applied to keep the block from sliding down the plane? Right? So we have a 2 kilogram block. We have a force of friction, and we have the force F that's required to keep this block from sliding down. I defined my axes as the X being parallel to the, or the X-axis being the actual plane itself here, and the Y-axis being perpendicular to that plane, right? So obviously in all statics problems, we know nothing's moving because duh. So we know that the sum of the forces in the X is going to be 0, as well as the sum of the forces in the Y is going to be 0, and that fact is going to allow us to solve for the unknown force in this case, right? So if we draw a free body diagram, we can see here that the, the force here, right, the force of gravity is going to be 20 newtons, right, because it's 2 times 10. Right, I use 10 because it's easier. You can use 9.81 or the one that's even more specific. 10 is easy, and you get really close to the answer. If not, if you're really worried about it, you can just use 9.81. So 2 times 10 meters per second squared is going to be 20 newtons, right? And then that force is going to have two components. It's going to have an X component that is parallel to the plane, and you're going to have a Y component that's perpendicular going along the Y-axis, right? So I labeled the Y component as Fn sub Y, and I labeled the X component as Fn sub X in this case, okay? So if you take this triangle that I drew here, ends up being a right triangle, if you do it properly. You take this triangle, and you flip it over, make it bigger so you can see what's going on here. And you label your legs and hypotenuse properly. You'll see that you have a right triangle with an angle, with the hypotenuse defined, and it's easy to solve for both legs, right? So notice the fact that the cosine of this angle, 34 degrees in this case, right? And also notice the fact that the degree of incline here is going to be equal to this angle theta right here. So so this is basically not this. This is this. So the cosine of 34 degrees is going to be equal to the adjacent leg over the hypotenuse. In this case, it's Fn sub Y, right? The adjacent angle to the adjacent side, to 34 degrees, divided by the hypotenuse. In this case, 20 newtons. And you do the arithmetic, and you get the fact that the Fny is equal to 16.5, and that's these are in newtons, right? 16.5 newtons. Okay. And then ultimately you can do the same thing for the sine. The sine of 34 degrees is going to be equal to the opposite side divided by the hypotenuse. That is also newtons, right? Again, do the arithmetic. You find that Fnx, in this case, which is this, Fny is that going down there, is going to be 11.2 newtons. Now, it's important in these problems, if the angle is not 45 degrees, that you're going to have one leg that's shorter than the other. In this case, it's the X component of the 20 Newton force, which is just basically the weight of the block. In this case, it is the X component, right? So make sure that your X component is smaller than your Y component. If you do your SOHCAHTOA incorrectly, and you put this as sine instead of cosine, your X component, you'll basically get the same numbers, but this will be the X instead of the Y, and that won't make any sense because, duh. So make sure that you get your legs, basically double check your legs. So once we know that, we can calculate the force of friction, knowing the fact that the force of friction is going to be equal to the force that's exerted on the block by the, or on the plane by the block. I guess either one is fine. Just the sign is different. One's negative, one's positive, depending on how you define your axes. Moving on. The force of friction is going to be equal to 16.5, which is the y component in this case, right? So that's the force that's exerted, again, on the plane by the block. And you multiply that by the coefficient of static friction, which was given in the problem, and you get the fact that the force of friction in this case is going to be equal to 3.3 newtons. And that's going to be the force that's resisting the motion. That's going to be right up here, right? So, if we only look at the x components, or the x forces, or the forces in the x direction, I should say, we know that they have to sum to 0, right? Excuse me. So, if we take down the incline as positive, you'll get that the x component of the force, right, x component of the weight, I should say, and then subtract that from the force that's required to keep the block from moving, and then subtract also from that the force of friction, right, because so this is going in the positive direction, the others are going in the negative direction, so that's how you get the sign. If you define up the plane as positive, you get the same answer. But in this case, I define down the plane as positive. If you do that, notice the fact that I can solve for f. I get f to both sides. That cancels, and then I have f is equal to the Fnx, right, the x component of the weight, and minus 3.3 newtons, right, that's force of friction. And you get that the force that's required to keep this block from moving, I get, personally, is 7.9 newtons. All right? So again, the hardest part is this part right here. And actually these two parts. Getting the proper free body diagram, getting the proper triangle, making sure you don't screw up trying to calculate the legs. And then once you have that, you can calculate the friction easily. And then use the fact that the sum of the forces in the x direction have to be 0, and you get the force that's required to keep the block from moving is 7.9 newtons. Hopefully this helped, and hopefully it's recording this time. And we're going to do more statics problems, we're going to do a whole bunch of other stuff. And so yeah, hopefully this helped, and we will see you all in the next video.